Alright, so this is question 19, and it says in triangle ABC, and it gives you that A cos A equals B cos B. So this is what it gives you, and we're going to use that condition. But the first thing it says is in triangle ABC. So I drew a general triangle here, you can see an ABC triangle, and of course the side opposite angle A is little a, etc. And then because of the condition which used cos A and cos B, that's what I found for this triangle. So here's my cos A, here's my cos B, and that's just straight off the triangle using the cosine rule. Now, I do exactly what it tells me to do. I'm given A cos A equals B cos B, so I use these equations and I put that into the given condition. So this is what we get. We just simplify it. There we go, simplify, simplify as we go down. And I'll put everything on one side because that's what we usually do to solve, for instance. So putting everything on one side, you can see we've got a few difference of two squareds here. So just look really carefully because it's a little bit hard to see, especially in this line. You can see these two terms both have a squared minus b squared in them because here we have difference of two squares again. So I can factorize by a squared minus b squared to get this one left, and then here I've got two terms, just be careful here, but two terms, and we know if a times b equals 0, either the a has to be 0 or the b has to be 0, so either this has to be 0 or this has to be 0 for this to work. So setting each to 0, you can see for this one a has to equal b, and if you go back to the triangle, if a and b are the same length, we've got an isosceles triangle. In the second one, we end up with c squared. And remember what you're asked to end up with. It says use the cosine rule to prove that the triangle is either isosceles or right angled. So if that first one was isosceles, we know this one's going to be right angled. So I'm looking for Pythagoras theorem, which is what we get. So we've proved that either it's an isosceles or a right angled triangle. I hope that helps.